All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be doing. So I'm not sure whether to say that we're gonna be doing performance optimization or. Okay, so in general, we're gonna be doing packing and unpacking of data. Today I'm gonna actually sit down and write down that entire unpacking logic for unpacking the body pose landmark data that gets received over the network. Actually, I mean, I wrote down most of it already. I just remembered that because I haven't looked at this code since yesterday. Because yesterday, after not yesterday, I don't think I streamed yesterday. I haven't looked at this code since the day before yesterday. Yesterday, I decided not to stream because I spent some time looking at. So there's a tool called IL Spy, which lets you see the IL, the intermediate language representation of your code. It also lets you decompile. So basically, you can give it a DLL, and it'll either decompile it down to IL or decompile it down to C# for you. And I was more interested in IL because I wanted to see what exactly is going on, how the code that I'm writing gets translated into IL instructions, because I felt like that would kind of give me an idea of how things are being laid out in memory. It's not gonna be like a precise idea, because it's gonna depend, because like the IL then gets translated to machine code during runtime, right? So it's going to depend how exactly that gets laid out in memory is going to be very much implementation dependent. So it's going to depend on like different architectures and different platforms and stuff. But at the very least, I wanted to get like a brief idea, kind of an idea, so I can kind of make assumptions when I'm doing my when I'm doing my coding. And I still need to read up on well, reread up, I guess. Read up on it again. I need to read up on garbage collection again, to understand how the GC works, because like it seems like, I mean, I'm going to be using it, because I mean you can't like completely avoid GC, or maybe you can if you try like really hard, but under usual circumstances you're going to be using the GC at least like a little bit. So if it is being used, then I would much rather have an idea of how it's working, so that I can once again make assumptions of how certain variables and how certain memory that I'm allocating is going to be laid out. That being said, what we are dealing with here is a byte array. Oh, another idea that I had. So, in the last stream, I think, or maybe it was the stream before that. I think it might have been the stream before that. I can't remember. One of the previous streams, I changed this message body name from a string to an enum. So now we have all three of these are enums, meaning they're ints, or they can be represented as ints. And then this is a byte array, right? So we don't have any strings here, which is great. Now, what I was thinking is this message. Just a second. I just remembered my VTuber avatar. Which, dude, I should do something to make this a little more dynamic. Now that actually, no. Once I have the body pose landmark system running more smoothly, then I can do something about it. Because, like, at the very least, something that I could do is I could try applying. So, like, I have 33 body pose landmarks, right? On the head alone, I have, so there's three for each eye, I believe. So that's six. Then there's two ears. That's eight. I don't remember how many are there for the mouth, but I'm going to count two for like two corners of the mouth. So we are at 10, and then the nose would be 11. Now, I don't remember how many more might be there, but we can like assume there's 10 to 11, right? And they do transform in various ways, or, well, at least on a two-dimensional plane, they will move in various ways. So what I was thinking is this part of my avatar could become the head, and then eventually there could be a body. For the time being, just a head is fine. I can I can have like a pivot point, and that can be like the neck. So then when the head is moving around, it's going to be moving relative to that. But yeah, that's the idea I have so far. So that's like one of the ways that I can start using. I mean, there's more ways because like I'll have hands. I'll have like all the body parts, like all the body pose landmarks with me. So I don't need to limit myself to just moving the head around. I can actually apply something to hands as well. So I could maybe attach some kind of particle system to the hands, and then have the hands and elbows move around. Oh, I could attach something to the elbows as well. That would be fun. Yeah, dude, we can do something like that. We can definitely do something like that. Oh, I'll also need to work on like a smoothing mechanism, so that's probably going to be before applying the positions to the avatar. I'm going to need to set up the smoothing mechanism. Yeah, okay, okay. So here's what I was thinking. I don't remember how I got to. Oh, yeah, the avatar. I was looking at that. Okay, so here's what I was thinking, right? We have a DVTMP message, but like this is meant to be, it's meant to be received over the network as JSON. And it's also meant to be sent over the network from the other app as JSON. There's no packing involved. The packing is whatever is being done by JSON. And this is great because it's like it's super convenient. I don't have to do any packing. But what I was thinking was I could introduce another type. I could introduce a DVTMP. Dude, I'm wondering if this should be a struct. Yeah, I'm wondering if this should be a struct. Actually, no. I don't think. Wait, no. Something that's gonna be, can JSON data be deserialized into a struct, or is it limited to a class? No, see, I think that's like nano optimization that I'm doing, which I don't entirely, I'm not entirely sure if it's going to if it's going to actually have any benefit. Because if it's just like, I don't know, microseconds or whatever minuscule bit of seconds. What is, hold on. Microseconds. Okay, so what does, hold on, before I say what I was about to say, I'm curious. So I'm just gonna look that up because I forgot if it's microseconds and then nanoseconds, or if it's nanoseconds and microseconds and then somewhere. Okay, hold on. Let me look it up. Okay, a microsecond is equal to 1,000 nanoseconds. So nanoseconds is smaller than microseconds. Wait, no. Hold up. A microsecond is equal to 1,000 nanoseconds, or 1/1000 of a millisecond. So is a millisecond, wait, if a microsecond is equal to 1,000 nanoseconds, that means nanoseconds are smaller than milliseconds. No, that means nanoseconds are smaller than microseconds. But if a microsecond is equal to 1/1000 of that is not easy to say. 1/1000, and then there's supposed to be a th there. But anyways, it's equal to 1/1000 of a millisecond. That means 1,000 microseconds makes 1 millisecond. So it goes nanoseconds, microseconds, milliseconds, and then is it seconds? Okay, so there's unit of time. I'm looking this up elsewhere, so just bear with me. I'm looking for a table. Time. Okay, let's just look at time. Measurement. Dude, let me just Google time. Oh, wrong. Oh shit. Wrong keyword. Time units table. Let's just Google that. Let's do time seconds. Time seconds units table. Because it goes down to seconds and it kind of stops there. People don't usually go below that unless like they really need to. Okay, so we have femtosecond, picosecond, nanosecond, microsecond, and then millisecond. Okay. All right. So would I be right to assume 1,000 milliseconds is 1 second? Yeah. 1,000 milliseconds is 1 second, and 1,000 microseconds is 1 second. Okay, so back to what I was saying. If the nano optimization that I do only gives me like, I don't know, what, microseconds or milliseconds of a speed boost, then I feel like that's a very minuscule bit of performance increase. But like trying to get that minuscule bit of performance increase, if it's going to be a massive headache, then I don't want to do that. It's just going to be a big waste of time for just a very, very tiny, probably negligible performance boost. So like, unless it's really causing a problem, I don't want to try and fix it. In this case, it was really causing a problem because I was, in this case, like the whole reason why I started doing the packing and unpacking thing was because this was causing a problem, because I was deserializing JSON data almost every frame. And well, JSON data is string. So it was there was a whole lot of allocation going on, and let's just say every few seconds the garbage collector was yelling at me. So I had to get rid of that method and do this unpacking thing where I'm receiving bytes and unpacking the bytes directly myself rather than receiving JSON data. Now, that being said, what I was wondering is maybe I could introduce a packed version of this DVTMP message. So I'll call it DVTMP packed message or message packed. I'm still not sure what naming scheme I want to go with, but that's a minor thing. I'll look at that later. For now, like what I was thinking is I could create a packed version of this for the future, where basically each of these fields would be represented as bytes. So this is going to be an int, so that can be 4 bytes, this can be 4 bytes, this can be 4 bytes, and this is this can be 4 bytes, and then this is a byte array. So we're going to need the payload size here. We're going to need the message body value size. So we can have like an offset, right? We can have an offset. I'll have to introduce a few extra fields. So like, to be honest, this doesn't have to be 4 bytes. The message type, it's a message app type. This doesn't have to be more than a byte. I'm never gonna have more than 255 message app types. Like, that's just not gonna happen. So this can be a byte. This can, I'll keep this as an int 16, but like I doubt that's ever gonna happen either. To be honest, I could keep this as a byte as well, and it wouldn't be an issue. And then this can be a byte as well, because like if I keep this as a byte, that's going to be 255 message body names. I highly doubt I'm going to have anything more than that. I mean, at some point in the future, if I do, well, okay then, but like, I doubt I'm going to have anything more than that. Like, by the time I get to that point, who knows if I'll even be using this app, or if I'll have moved on to like a different kind of app. And then this can definitely be a byte. Yeah. To be honest, both this and this can be packed into 1 byte, but I'm not going to bother doing that because that's just unnecessary. It's unnecessary extra work. I don't absolutely need to pack it down that tight. Each of these can be a byte, right? And then this is going to be a byte array. But just so we know the size, so I'm going to like include an extra field, which would be, the extra field would need to be an int 32. Let's make it an int 32, even though I'm probably not going to be sending more than 32. Hold on. So we have 8, we have 16, and then we have 32. Was it 16 that was limited to 65,000? I keep forgetting. Hold on. 16-bit max value. Yeah, it's int 16 that's limited to 65,000. And I doubt that any of the messages that I'm sending are ever going to be that big, because I believe there is a limit. Well, no. I mean, there is a limit, but like if you go past that limit, so like below the UDP protocol, there's another protocol that, well, that's what, like, that's on a different layer. And your message, it gets passed down to that layer where your datagram then gets split up, if need be, into multiple packets. I forgot the name. I think it was the IP. I think it was the IP layer. Well, no, it's I forgot the name of. Maybe it's the network layer. I don't remember, but like it gets split down, I believe, into IP packets, and the size of it will depend on something called the MTU size. I think it's I forgot the full form, like what maximum transmission unit size, I think. So like I'm not really doing that kind of, like I'm not worrying too much about that. But like in general, like from a higher level standpoint, I'm probably never going to be sending 65 kilobytes worth of data in one message. Usually if it's going to be that big, then actually I'm saying that right now, but like it might happen. I did try to do that. I did try to do that previously. But yeah, okay, just as a rule of thumb, what I want to do is, if it's going to be that big, then I want to like divide it into chunks. Fortunately, I am finding like ways to squeeze the data down. For example, the body pose landmark data. I remember at one point I had to increase the array size, the buffer size, the buffer that's going to be receiving the data. I had to increase the size of it because it was throwing an error because there wasn't enough space, right? And I was getting, well, I don't remember exactly. I don't remember if it was 16K or 32K that I was getting, or if it was slightly more, but it was a lot because it was a lot of text that data was then getting. The data itself wasn't that big, but it was being converted into JSON data, which is where a whole lot of the wastage was coming from. But now I have managed to take that down to 660 bytes, which is amazing. Well, 660 bytes with a few extra bytes added. So let's say 680 bytes because we have a few extra fields. I don't remember what all they are. Hold on. Let me see if I can find it here. It should be here. Yeah, so we have the landmark count. Oh, that's about it. Yeah, that's 1 byte, the landmark count. So it's 661 bytes. I've compressed it down to that. For the raw message itself, there's going to be a few extra bytes added. So we can consider that the raw message is header. Maybe I should start calling it the header. Because like usually that's how you see it with like the protocol. I'm not always designing protocols. So like my terminology is, my naming, it's not necessarily going to be consistent with that. But yeah, it makes sense to call it a header, right? In the format, we have the magic number, we have the payload size, and then we have the payload data. So the magic number and the payload size can be part of the header, and then we have the payload data itself. I mean, it's a small thing. It doesn't make too much of a difference. But yeah, okay, once I do introduce the packed form of DVTMP message, then I can just add an extra thing here. Oh no, what just happened? What did I just... How did I just do that? No, don't close it. Don't close it. There's probably some split thing that I did. There's probably some combination, some key combination I hit that caused it to split. So anyways, oh, that's how I did it. Okay. Oh, okay. All right. I'm not sure what this is supposed to be, but I'm definitely going to explore this more later on. Okay, cool. So once I've introduced a new thing, the DVTMP packed message, I can just add it over here. And then I'll need to come up with the mechanism for, unpacking the data as well. But yeah, that can be a nice performance friendly alternative for situations where I need to, actually, DVTMP packed message could have been just a second. I need to hydrate. So it occurred to me today when I was thinking about the packed message, like when I got the packed message idea, it occurred to me that, I could have avoided having to create a body pose message protocol if I would have just made a packed version of DVTMP message. But like, I need to think about what kinds of what drawbacks would I have seen there? Because trying to make like a one size fits all solution, something I've realized having tried to do this multiple times with past projects, trying to make a one size fits all solution can get convoluted very quick. As you try to introduce more and more things and you try to fit them to that one size fits all solution, things can get really complicated. On the other hand, if I keep things simple as to where, okay, the body pose message, it had like a very specialized use case, right? So I made like a separate protocol for it. But then DVTMP message, I can have like a JSON version, and then I can have a packed version. And the packed version can be used in scenarios where I need to be sending data more often. And I don't want to deal with, the GC issues that arise from deserializing data every frame. I can use it for those kinds of scenarios. Yeah, yeah. Okay. So I'll get rid of this. I still need to go over this whole list again, this entire notes, app notes thing again, and just make sure the data is still accurate, because the design started out as something different, and now it's been iterated over. It's been improved over. Okay, so we did what needed to be done over here. Right now, what I need to do is create a message and then pack it. So I need to come up with the packing mechanism as well. So let's create a function here. Test packed data. Wait, is IntelliSense not working? Oh yeah, it's working. Okay. Test packed data. So what I want to do is, well, just call test packed data whenever I hit space. And then in here, what I want to do is create an array. So that's going to be a landmark array. I'm wondering if I should keep this as a struct or change it a little bit. Because like, okay, it's mainly meant to store data. It's not, it's at least for the time being, it's only meant to store data. It's not meant to, it doesn't even have like its own functions. It's not doing anything complicated. It's mainly just storing data in it. I can leave it as a struct. Okay, so landmark array. We are gonna create, I need to find a way to populate this thing 33 times. Okay, so let's create landmarks equals new landmark 33. Okay. Then for each landmark, we can have like, okay, so we can randomly generate data. Would for each work for this? Because like a collection has to have like certain things implemented if you're going to be able to use it as a. Oh, hold up! It's all empty. Isn't that going to throw an error? Okay, you know what? It's not a problem. I less than landmarks dot length I plus plus. Okay, so the first thing we need to do is, do we need to initialize structs? I don't remember. Hold on. I think we need to. Yeah. I think we need. No. We need to. We need to. Yeah. I believe it's necessary. It is. C sharp do structs need to be initialized. Beginning with C sharp 11, if you don't initialize all fields in a struct, the compiler adds code to the constructor that initializes those fields to default values. The compiler performs its usual definite assignment. Okay, there's an ad playing, so I'm gonna, well, sit quiet for like 30 seconds, I guess. Actually, I need to take a short break, so I will be back. All right, I am back. So, um, we need to initialize a new instance of each of these. And what I could do is, I could initialize it with a random value. So we can do random dot, what was it, Unity engine random? Yeah. Hold on. Is this system.random? I think this is system. Yeah, this is system.random. That's why it's creating an issue because we have... Okay. Can I create... I forgot if you can create an alias for types. Can you create an alias for... Hold on. Class alias. How do I alias so-and-so? You can alias the class. You just have to use the fully qualified name to do so. Okay. Okay. Where's the answer? You can't. The next best thing you have... the next best thing you can do is using... Oh, using. There you go. Is using declarations and so-and-so, for example. Right, so I could do this, right? Using Unity, no. RND, or RND equals Unity engine dot random. Would that work? Man, jumping between multiple languages, it becomes hard to remember shit sometimes. Okay, great, awesome. So random dot range, what do we want? We can do between... It's normalized, right? So we want it to be... Wait, is it... So it's normalized, but is it signed? I think it is signed, right? I forgot where the center of it is. Not center. I forgot where 0 would be in the image. Would it be in the center, or would it be in one of the corners? At least like from the media pipe standpoint. What is it giving? I think... Shit, I can't remember. I'm gonna have to look at that. But okay, it doesn't matter. We can do this inclusive, and this is also inclusive, right? Okay, great. So 1.0f, 1.0f, and then we can do the same thing for all of these. So it has to be y, z, visibility, and presence. So now we have an entire random... We have an entire landmark pose with random data. And then with the for loop, we'll have an entire array with landmark poses with random data. Great. So now we pack the data. Okay, so we create... I forgot what the protocol says. It's okay. I'm not sure if the stream is still going or not. Oh yeah, okay, it's still going. Great. So that was weird. I had like a little hiccup in my internet connection. Fortunately, this time it wasn't my USB to Ethernet adapter. I got a new one, by the way, and the issue still seems to be happening. The issue has been happening since I started using it. So and I've even over time I switched USB ports, like from one port to another. I instead put my audio interface USB into the other port where there was the issue, and then I switched it off. I switched both of them with each other basically, and then the problem wasn't there for some time, but then it came back again. So like, I don't know if it's just an issue with the USB to Ethernet adapter, like it's just a thing that happens sometimes. Maybe I'll need to get a better quality one, or maybe this is just something that's very common with these kinds of adapters. Either way, this little hiccup that I just had was not because of the USB to Ethernet adapter, because the issue showed up on other systems where I'm using the internet as well. So either way, okay, we can carry on. Enough with this. So we create a byte array. By the way, I'm considering whether I want to use stack alloc, because I looked into it, and a nice simple way for not having to use the unsafe context, because like usually you could only do stack alloc in an unsafe context, but like one way to not have to do that is to use span instead. So I can then create a byte array and then do stack alloc byte array 1 2 3, right? And then I can do whatever work I'm trying to do here. But like what I'm trying to do is make it so, and this is like a nano optimization, but I want to see if I'm able to do it, if I'm able to pull it off, because I want to try and, but like the issue is there's still going to be an array. It's a byte array that's being received. That byte array is being unpacked. We read the first byte of it, and we find out that it's a body pose message, and then we send the entire byte array here. So it's already being sent, it's already being passed by reference, right? Over here. It's being passed by reference. So the thing is already like allocated on the heap. I need to find a way to make sure that this entire array is allocated on the stack, but at the same time, I'm able to pass this around to like from message to from method to method. One way to do that would be to pass the entire array by value, and that's basically duplicating data and then, you know, filling up memory. But like the data is not that big. At the same time, I don't know if it's going to be more trouble than it's worth. Like, is it actually going to give me that big of a performance boost? I'm not entirely sure about that. Yeah, I'm not entirely sure about that. Because like it's passing the pointer around, isn't it? It's passing a reference, and like the reference is basically a pointer to the location in on the heap. Now I need to figure out if having this entire array on the heap is that big of a detriment, or if I'm just assuming, because I don't think it's going to be that big of a detriment. Like, sure, there will be garbage collection happening, but how do I put this? Like, the system is not that primitive. There's a lot that goes into, like, there's a lot of thought that's been put into it, and the garbage collection system has like a fairly complex set of rules that it uses to decide what stays and what goes, and there's like performance optimizations being done there as well. So I don't think I need to I don't think I need to operate under the assumption that that system is primitive. That being said, if it's just 660 bytes, I wonder if that's really that big of a deal for it to be on the heap and then be discarded. But like, something I want to do is have the thing live infinitely. That's something I want to do. If I can just have that block of memory live on forever on the heap, because like the heap has like multiple. It classifies like your data into being like short-lived, medium-lived, and long-lived. So I need to find a way to make the variable long-lived, so it just never dies. And I guess one way to do that would be like, what if I declared it at the class level? Would it then just live on the heap forever? Because this script is not being shut off ever. It's gonna run throughout the. Well, I mean, it might shut off if the scene changes, but like we are not changing the scene. So like that's one way that we could do it. And then I'm not allocating new. Well, that's not entirely true. Actually, no. Okay, I'm not allocating a new array here. Oh, though, I am copying data here. I just realized that. So I'm definitely creating arrays here. So if I could make sure that all of these, though even with this, right, it comes like, I come back to that same thing of like, am I doing nano optimization here? Am I doing unnecessary optimization here? Like, would I really see that big of a benefit from where is it? Landmarks, landmark count, payload data. Would I really see that big of a benefit from making payload underscore data stack allocated? Would it really be that big of a difference? Because like if the entire thing is stack allocated, then my assumption is that the moment we exit the method, then it just, you know, gets the pointer moves, and then it's just not being used anymore. The stack pointer is going to move, and all the data is going to get cleaned up. Not cleaned up, but like written over eventually later on. I don't know if it necessarily zeroes it out, because I'm looking at it from like the function prologue and epilogue point of view, where you create a prologue before you enter a function, so you're setting up the stack frame, and then once you exit the function, there's the epilogue where you basically reset it back to the way it was before it entered that stack frame. So like my assumption is that if the array is being allocated on the stack, or the stack for, you know, that if it's being allocated within the stack frame of that method itself, then the array is also going to get cleared out once the function exits, which is great. Right, but like, okay, we would still have the raw message bytes data on the heap, because there's still like a reference to it. Right, that reference is how we are passing it here, unless we want to actually copy the data. And like if I did do that, now we are duplicating data. But are we seeing that big of a performance boost that it's worth going through that headache? I don't know. We're gonna carry on with this. I have to think about this kind of stuff. I don't know if I have to, but I keep thinking about this kind of stuff. Okay, Anyways, so we'll create a byte array, call it packed data. And this would be landmarks dot length plus, oh wait, this has to be a constant, doesn't it? No, this doesn't have to be a constant, does it? Would this work? I had an issue previously where I tried to assign something in an array, but it wouldn't let me give a variable. It said that it had to be a constant value. I can't remember what the scenario was. But okay. So landmarks.length multiplied by, it's 5, right? We have 5 bytes. No, nope. Hold up. Multiplied by 5 multiplied by 4. Yeah. So there's that, and then there's this. So the first byte is supposed to be okay, 5 multiplied by 4, 20 bytes. 20 bytes is per landmark, and so that multiplied by the length is 660. Plus 1 would be 661. Okay, so the first thing would have to be, I think 1, right? Because it's raw message data that we are looking at. No. We are looking at packed. Should I just construct an entire raw message? Okay, no. Yeah, we can construct a raw message later on. For now, we are constructing packed data. So what is it supposed to contain? It's supposed to contain the landmark count, which is 33, and then the remainder of it would, so we would start at 1 and then go all the way to the end. So for int I equals 1, I less than, no, I equals 0. We are iterating over the landmarks array, right? So we need to create a counter or an index. So let's do int, what would it be? Yeah, let's just call it packed data index equals 1. So we start at 1, and then we need to run we need to run the bit converter dot to single, no, bit converter dot get bytes. Okay, so how do I go about this? Bit converter dot get bytes. Get bytes returns a byte array, right? So we can have a byte array. Let's just call it this, equals get bytes. Get bytes of landmarks I dot x. Okay. All right. Yeah, that makes sense. That makes sense. And then we need to run a block copy. What was it called? Buffer.block copy. We need to run it from here. So it's going to copy from here at offset 0. To here, packed data at packed data index, and we want to count 4. Is that right? I think that's right. I think that's right. And then packed data index plus equals 4. So now I can create copies here. And I guess that's it, right? Oh wait, no, I have to change. Y, Z, visibility, and presence. Okay, so at this point we should have our packed array, our packed data, and then we can create a raw message, which would be another byte array. So this would be raw underscore message underscore bytes equals new byte. The size of this would have to be, hold on, let's go back to the protocol and see. So there's a magic number and then there's 4 extra bytes there. So that's 5 bytes plus the size of this thing, the size of the payload data. Okay, so it's 5 plus what is it? Packed data dot length. Okay. Give me a second. Let me hydrate. Okay. All right. So in the first byte, the first byte is a magic number, right? So raw message bytes 0 equals 1. And then we want to do, wait, we need a byte array. payload size underscore bytes equals what is it, bit converter. What is bit array? I've seen this like over the years so many times, but I've like barely ever used it. Let me just look it up real quick.
YouTube Premium is ad-free YouTube and the YouTube Music app altogether. One subscription.
Let's see if there's like a stack overflow. Is bit array faster in C# for getting a bit value than a simple... Wait, let's read this. Manages a compact array of bit values which are represented as booleans, where true indicates that the bit is on and false indicates that the bit is off. Okay. So like, yeah, conventionally you would be using like bitwise operations to do this kind of stuff. But I need to see if this is faster. Hold on. Okay, so these people are doing like benchmarks and stuff. Okay. Bit array is going to be able to handle an arbitrary number of Boolean values, whereas a byte can only hold 8. That makes sense. And only 32, etc. This is going to be the biggest difference of the two. Also, bit array implements IEnumerable, whereas an integral type obviously does not. So it all depends on the requirements of your project. If you need an IEnumerable or array-like interface, then go with bit array. Okay, so it seems like if you want to use more of like the programming features or programming concepts, if you want to be able to do more like high-level stuff, then you're better off with bit array because it gives you like more convenience. I don't know about the performance because I haven't tested it myself, but like I'm assuming they tried their best to make it as performant as possible. Whereas if you're doing the same thing with just plain bitwise operations, then as this person mentioned, of course, you would be limited by the data type itself, because a byte can't hold more than 8 bits, and int32 can't hold more than 32 bits. So, yeah, okay. Carrying on with what I was doing. So, get bytes. Dude, I need to look into... Like, I've gone over this thing before as well, but I don't think I've gotten a proper answer. Okay, hold on. So, what are we trying to get? Packed data length. Alright. What all does packed data contain? Packed data contains 661 bytes. So, it's going to put a value of 661 in the form of 4 bytes into this. Alright, great. Now, what else do I need to put? I need to put the magic number. Then I need... Oh, wait, yeah, I need to copy. Buffer dot block copy. Dude, I need to check if this generates any garbage at all. Real quick, let me just confirm that. Buffer dot block copy. Garbage. Garbage collection. I've located the problem to be buffer.blockCopy method. If I remove the blockCopy command, the memory used by the application will be half the size. I disagree with this conclusion. The byte array exists and is filled with data. You allocate the float array, but it isn't filled with data yet. You fill the float array with data, the byte array isn't referenced anymore, but hasn't been collected yet, and then the byte array has been collected. The life of the byte array isn't influenced by block copy. Yeah, okay, hold on. So I should probably add this to my to-do list. Let's go all the way to the bottom. Okay, research. Memory allocation of class variables and how to make a variable never be garbage collected. Because I do have, like, this seems like one of those scenarios where I would definitely need the entire thing to exist throughout the, like, it doesn't need to be garbage collected. Some of the other stuff needs to be garbage collected, but, like, you know, I could make these variables class level and then they'll just never be garbage collected. So I wonder if that would give like a tiny bit of a boost or well, not a tiny bit of a boost in performance, but like that would avoid a certain level of garbage collection. Okay. Yeah, wait, no, I was googling this. Hold on. Does buffer.blockCopy generate garbage? This creates a byte array, bytes intermediary object, which becomes garbage, presuming a ref is no longer held to it. Copying variables into buffer without creating garbage. Use pointers is the best and the fastest way. You can do this with any number of variables. There is no wasted memory. The fixed statement has a little overhead, but it's too small. Okay. Okay. There's a byte by byte copy of the bytes and so on and so on. Dude, I'm wondering if I should start looking into like the pointer side of things, the unsafe side of things in C#. Because I haven't done like any pointer related stuff in C#. But if it's gonna benefit, then I'm wondering if I should do it. Because like this is an operation that's going to be happening close to every frame. So like I want to get as much performance out of this as I can. Now, all of these arrays that I'm allocating here, I'm wondering if all of this is going to like generate an unnecessary amount of garbage. Yeah, I need to, after I'm done with this logic, I'm going to need to do some research on like what can be the possible drawbacks of doing this like every or yeah, what can be the possible drawbacks on like garbage collection of doing this every frame, because like this is going to be happening close to every frame. Okay, so we are copying from payload size bytes. Wait, what's going on here? Oh, it's packed data. Okay, packed data. I should have called it payload data. um at 0, and we want to copy it into raw message bytes. At what offset? That's a good question. So I think it's at offset 5, right? So it's 0, 1, 2, 3, 4. And then 5 is where we start. Okay. And then the count would have to be packed data dot length. And then I think our raw message bytes is ready. Now I need to add a debug thing here just so I can get at least the first one. So we can do landmarks 0. Oh, wait, let me construct an entire thing. Wait, what would happen if I just printed out landmarks 0? Would it print out the entire thing for me? I can't remember if, or is it just going to say that it's an instance of this thing? I'll see. I'll find out. Okay, so after that is done, let's call some function and pass in raw message bytes. Now in raw message bytes, once the entire thing has been decoded or unpacked, then also I want to do a debug.log landmarks 0. So we need to compare these two and see if we get the same result. I'm not expecting this to work right off the bat. There's probably going to be some logic issues I might have missed, because like we are working with like byte offsets here, so there's a decent chance I might make a mistake somewhere. But let's see. Let's see. So we are going to open up the Unity editor. We're going to let this thing do its loading thing, and after that we'll run the script. Is the music still going? Nope. Music paused. Okay. All right. So I'm trying to open up Unity, and okay, so it's doing the waiting thing again. Right. So while this does its thing, maybe I could look into something. I could do something. I don't want to change anything here right now. Oh, let me just take a look at the code. Let me take a look at the logic here. So we get the payload size, then we get the payload data. We're doing buffer.block copy. Okay. Just a second. Okay. So we do buffer.block copy. We get the payload data. We I'm sure there's a much more or a much less wasteful way of doing this. This thing that I'm doing where I'm like dividing it up into multiple variables, that might have a bit of a drawback. It might have a bit of a penalty. But I need to see if that penalty is really that big that I need to worry about it. The issue is like this is going to be happening multiple times, so that's why I need to worry about it. Because like that's then going to generate a ton of garbage, and I need to avoid doing that as much as I can. Because like I doubt this is going on to. Oh, one way that I could avoid it is using span. So that's one thing I could do, where I could avoid having this go onto the heap. Because if it's just a single variable, then it's a different situation. Then it's going on the stack, right? But if it's an array, then it's going on the heap. At least that's what my assumption is. Oh, is it done? I think it's done, right? Nope, it is not done. Just like yesterday, it's taking time again. It's one of those things where it's like the first run, or when you've run it, or when you've not run it for a while, and then you try to run it again, then it kind of takes some time to get up and going. At least like that's the thing that I deal with on a regular basis. At least with Unity. Um, let's go back here while we wait. Okay, here's something I could Google. Unity allocating array every frame. How to make array object allocation faster. Oh wait, yeah, no, I forgot. I don't need to do this. One thing that I'd come up with was I was gonna put the variables here. And that way I would be just changing the data in them every frame, every time the thing is called. So I don't need to allocate a new array each time. Okay, so I'm Googling something here. Wait, is Unity done? My god, dude, you are just taking your own time. This has been going for what, like 5 minutes now? Holy shit. Okay, so I'm reading something that somebody wrote. Each array is a separate object instantiated on the heap. Could you get away with a single giant array instead? So that's one of the things that I was thinking about here. Was that okay? So we have the raw message bytes, right? What if I just operated on offsets? That makes it like really complicated in terms of figuring out the offsets, but though, I mean, at certain points I would need to store the data somewhere, right? Oh wait, are we good? Are we done? Yes, finally. Okay, let's just confirm. Where's that object? Was it game object that had some script O2? Yeah, okay. So we're going to run this. And then we're going to hit space. Okay, there's an error. Oh, okay, it's a socket related thing. That's fine. So I hit space and we have an issue. So the issue is hold on. What is that? What does that say? Index out of range, index was out of the bounds of the array. Now what line did that occur on? Line 75. Okay, let's take a look. Line 75 is some func 03. So our issue here oh, wait a second. Hold on. So we're going to need to debug here. Debug.log raw message bytes. I need to make sure that the message bytes that I'm receiving, the bytes that I'm receiving do actually contain the data. All right, let's run this. And so we got 600 and nice. We got 666 bytes, which makes sense. It's 661 plus 5. Okay. All right, so that's our... Okay. So that's fine. Then let's do debug.log payload size. Oh, wrong one. Give it a couple of seconds. Okay. So let's run this and do that. There you go. Payload size is 0. So we have a problem here. The start index is supposed to be 1, but the... What is start index? Like I assumed that if I said start index, it's gonna start reading at index 1 and read the next 4 bytes. So 1, 2, 3, 4, 5. No, wait, 1, 2, 3, 4. So 1, 2, 3, and 4. It would read those 4 bytes. That was my assumption. Okay, so this is gonna be a little... Let me see. Let's print out the entire thing, just to make sure that there's some data in there. Oh my god, what just happened? Okay. Alright, so s plus equals this, and then this, and then this, I. Okay, alright. And then debug.log s. Okay, so let's see if there is any data in there. In the meantime, let me Google. Hold on. C sharp bit converter. What is it? Get bytes. No. Was it get bytes? No, it was to int 32. Okay. So what is start index supposed to be? Yeah, returns a 32-bit signed integer converted from 4 bytes starting at the specified position. Okay, that's what I was looking for. So the starting position with the value. Okay. Okay, so what data are we looking at here? The data says 33, right? 0, 1, 2, 3, 4. It says 30. It says 33 right there. So what's the problem? Why is this not? Give me a second. So this is our data. So that's the magic number. Then this is the payload size. 1, 2, 3, 4, 4. Oh. Wait a minute. Hold up. Was the first thing supposed to be a byte? The first thing was supposed to be a byte. The first thing was supposed to be a byte. How did I place the... The first thing was supposed to be a byte. But then the next one... Wait a second. So packed data is not the issue. The issue is somewhere here. Get bytes. We are getting the bytes of an... What is it, an int? It's an int, right? It's an int. Okay. So we are getting the bytes and then we are copying... Oh, wait a minute. I'm supposed to be copying the payload size. Where am I copying the payload size? Oh, I never copied the payload size. So 33 is not the size of the payload. I just realized that. Holy shit. 33 is the landmark count. I never copied the payload size. So let's do another thing here. We want to copy from payload size bytes into raw message bytes, but we want to start reading from here. So payload size bytes is supposed to be, it's an int, right? So it's gonna give us 4 bytes and then this is, okay. So wait, no, hold up. Payload size bytes dot length. Yeah, now we should be good. So now let's test it out. Okay. Let's go, dude. Okay, alright. So I need to write a thing here that would give me the entire... So... Oh, there's an ad playing. Oh, you know what? I'll hydrate in the meantime. Okay, welcome back. So I'm just constructing this entire string. I don't know what happened there. How did that happen? How did I do that? Okay, anyways. Uh we'll do this and this and this. I don't think I can go on the next line with these, right? Okay. Is the music still going? Let me just confirm. Okay, we are still good. By the way, shout out to Machine Supremacy. Go check them out. Pretty awesome band, pretty awesome music. If you like video game inspired music, you'll enjoy their stuff. Okay, presence. And I think that's good. X, Y, Z, visibility, and presence. Now I need to copy this here.
شاهد الفيديوهات بدون إعلانات أو إنترنت مع إمكانية تشغيلها في الخلفية. جرب يوتيوب بريميوم مجانا.
All right, and go back into Unity. Okay, let's test. Let's see if the values that we... Oh, wait, no, I meant to maximize it. Hold up. Okay, the values that we are looking at here, let me just clear this again. Okay. That is a little bit small for me to read, so I'm going to copy the messages here. Okay, we have that. And then next we have this. Okay. Dude, okay, we are good to go. We are good to go. We are now able to pack the data and unpack the data. So the packing part, I'm not going to be doing it on this machine. It's going to be done in a Python script, because like the Python script, the whole media pipe thing is running on another system through a Python script. And so I'm sending the data over to this machine from that Python script. So I'm going to be doing the packing there, but I wanted to work on the packing logic here so that, you know, well, first of all, I would be able to do it on stream, but also because it's just so much more convenient to create like a test debug method and use that, and then later on I can transfer the same logic into Python. So now all I need to do is work on the logic work on basically porting this logic into Python. I need to work on the logic to construct or pack the landmark data into an array and then construct a raw message byte array out of that, and then send that entire byte array into this machine. And after that, we should have, well, basically we won't be doing any JSON stuff for body pose landmarks after that. We are mainly only working with bytes and ints and floats and stuff. There's no string stuff involved. So that is great. That is awesome. Okay, what else did I want to do? I'm kind of tempted to rework the same logic in Python. In Python, it might be, I think it might be a tiny bit easier. I'm gonna need to see how, because like the performance stuff that you have to take into account with C# is different than the performance stuff you have to take into account with Python. But like both of them have things that you have to take into account when it comes to performance. So when I'm working on this logic on the Python side, I'm going to need to see if there's anything there on that end that could cause a hitch. I'm going to need to do a bunch of research for that. Yeah. Now, what else did I want to set up here? Was there something I needed to change? I think there was something I needed to change, right? So, okay, we set up this thing here for if the magic number is body pose message. I'm wondering if I should set up something for... Oh, you know what we could do? Just for fun, we could design the DVT-MP packed message protocol. We can put it here. Okay, so let's say DVT MP packed message, or should I call it message packed? Because like message packed would be more like, okay, we are going in line with the DVT-MP message naming scheme, but we just add the word packed there to mention that, yeah, this is a different type. This is packed. It's still a DVT-MP message, but it's in a packed form. It's not in JSON form. I think I'll go with that. Message packed protocol. So in a DVT-MP message, we have these fields. Oh my god, what just happened? I accidentally hit Control V instead of Control C. Okay, alright. So going back here. So message type is gonna be a byte. Honestly, dude, I could be careless with this. Hold on. Let's say byte 0. Dude, let me change the language. No, what is it? Text? Mode? I forgot what was it? Change language mode. Okay. Plain text. Great. Awesome. So, byte 0 would be message type. Byte 1 would be the message body name. Byte 2 would be the message body value type. And then we would have bytes 3 to n being the message body value. However, we need the message body value size. So that's going to be another thing, right? And the size, we want it to be an int32, though it can be an int16 as well, but like, let's just give it 32. So byte 3 to, what's it going to be? 3, 4, 5, 6. You know, each time I do this fucking counting thing, it gets confusing because I have like multiple like doubts that I get. First of all, we are counting from 0, right? But then on the hands, we are used to counting from 1. So like when I'm counting on my hand and I start counting from 0, then I'm like, okay, fine. Okay, so I need to keep that offset in mind. And then it's like, okay, all right, so if I land on this number with my finger, am I supposed to count that? Like, am I supposed to count that number, or is that number not counted? Or am I also supposed to count the next one? Okay, anyway, I'm not doing a very good job of explaining. Okay, 3, 4, 5, 6. So 3 to 6, right? So 6 is inclusive. I guess that's what I was talking about just now. So like, which one, what would be inclusive and what would be exclusive in this case? But like, yeah, bytes 3 to 6, which would be, what's it, 3, 4, 5, 6. Okay. See, okay, this is one of the reasons why it's confusing, right? We are counting bytes 3 to 6 would be 4 in total, right? Bytes 3 to 6 would be 4 in total. But 3 plus 3 is 6. This is where like my confusion comes in, but then I have to like remind myself that, oh, we are including 3, but 3 plus 3 is we are adding 3 to 3. So like it's like a short period of confusion, right? So message body value size. Oh, this is not required. Okay, right. So then from byte 7 to n would be our message body value. Right, so this is going to be a byte, and then this is going to be a byte, and this is going to be a byte, but this is going to be an int 32, and this is going to be a byte array. Oh wait, don't save. I just instinctively hit Control S. That dialog will be popping up any moment. I don't know if it's going to show up on stream. Because it's a separate window. Anyways, okay, so this would be our protocol then. Now I need to think about whether anything more is required here. Because I don't think I'm ever gonna have, so like, okay, if we're talking about message body name, I don't think I'm ever gonna have more than, oh, wait a second. If it's being defined as an int, I'm going to need to make sure that I define it as, I typecast it to a byte before sending it over here. Because otherwise that's going to cause issues. Because if it packs the data on the other end as an int, then it's going to be producing 4 bytes. Not 1 byte, right? So that can cause an issue with our calculations. Now, another thing I could do is just not worry about bytes and just use ints everywhere. Because like, well, not what I mean by everywhere is like any other situation where it's going to be a single byte, not like a byte array. Any situation where I'm expecting a single byte, I could just do an int instead. It's going to be wasteful, but it's going to be a few bytes worth of waste. So it's not really that big of a that big of an issue. Um, I mean, would the amount of memory that the GC has to release affect the amount of time that the release takes? Like, if it's would there be a big difference between releasing 5 bytes versus releasing 100 bytes? Or maybe a bigger example, would there be a big performance difference, or would there be any performance difference between releasing 600 bytes versus releasing 1K bytes? I should read up on the garbage collection. Like, they have like a whole section dedicated to garbage collection. So like there's multiple sections there that I can read. And I have read it actually before. It's kind of interesting. This is one of those topics that like I don't have to look too deep into it very often, and so I'll read it and it'll stay in my mind for some time, and then I'll just forget about it. I'll just remember a few things from it here and there that, oh, okay, yeah, this, I need to remember this, I need to keep this in mind, keep that in mind. Okay. All right. So now here, message body value size. That's going to give us the size of our message body value payload. Right? That's going to give us the size of the array that we are, supposed to do something with. But like in general, the message body value, message body value type, in a way, it dictates what the message body value size would be. Because at the moment, I don't think I have byte array as part of it, do I? I had it somewhere here. I wanted to add it. Like, I had I wanted to add it, but like I don't think I ever did. So like what I had was message body value type int32, single, which is a float, char, which is 1 char. So that could also, well, that's going to be a number, like an ASCII character, and then string. String could be, okay, string could, yep. String could be like an arbitrary amount. I also wanted to add like a blob, just like a bundle of data. Yeah, I wanted to add something like that. I just couldn't think of like a decent way to do that. Because like, well, no, I had some ideas, but like I wanted to think it over a little more before I went and added support for it, because I wanted to be able to send like just arbitrary data within the message. Right now, the way that it's designed, message body value can either be an integer, a float, a char, or a string. Right? Each of these, like the value types, that I'm gonna know how to decode it, right? But if it's just a byte array, I'm not really gonna know how to decode it. However, depending on the kind of message that it is, or depending on depending on the message body name, whichever event is being fired, whichever event that this or whichever. So depending on what the name is, this message, this entire raw message is going to be sent over to, like, some event is going to fire, and this message is going to be sent into that event, and then whatever method has subscribed to that event, whatever method is then being run, because this method was invoked, that method will know how to deal with with the blob of data that it's getting. So in a way, the messaging system can be agnostic. It doesn't need to worry about what the blob of data is. However, oh wait, nope. Well, yeah, yeah. Because like, okay, what I'm thinking now is like this is gonna be JSON. Yeah, this is gonna be JSON. Uh, if this was all done like completely as in the packed form, man, that would be like so much more performance friendly, wouldn't it? I mean, actually, yeah, no, I think it would be. It would also be a huge headache to like set that up because like look at how much time it took me to set this up. And the only reason I'm taking the headache of doing this is because I mean I like working with bytes. It's fun, but it's tedious as well. And the only reason I took the time to do this was because there was an actual performance impact of doing JSON deserialization every frame. But yeah, I could add, yeah, let's add that to my list. Look into adding a new type to dvt mp message byte array. Let's call it blob. This type will contain arbitrary data which will be unpacked by the by the method that is using the data. Okay. Okay, where did I have that open? Okay, all right. Just a minute. All right. So we are yeah. All right. So that's gonna be it for today's stream. I was just looking for someone to raid. That's why I was quiet for a bit. Okay, so that's gonna be it for today's stream. I'll be back tomorrow, maybe, or the day after. I'll see. I still have like a bunch of research to do, and I'm gonna carry on working on this. After work on the adding the packing logic, creating the packing logic in on the Python side. So I'll do that off stream, or maybe I might do it on stream as well tomorrow. I don't know. We can see. But yeah. That's gonna be it for today's stream. I hope you guys have a nice day, and I will see you all next time. Peace.